Hey guys, Mahesh here. Today I'm going to talk about deep learning. So everybody is using deep learning and I'm very sure people have seen a lot of application around deep learning. But there is a lot of black box around it. So my goal is to explore and show you what exactly deep learning is. Okay. So the people who don't know me, so I have 14 years of experience in the data. I've worked with multiple consulting firms as well as in banks. The idea of creating this channel was to make sure that I can share my experience and it can be useful for anybody, a student, a data professional, as well as corporate. So let's dive in and let's try to understand what is deep learning. Hey guys, let's understand what is deep learning. Okay, before we understand deep learning, it is very important to understand the pyramid structure of AI, ML, and deep learning. So in AI, so basically AI compresses of any kind of machine that can mimic human intelligence. It can be simple rule-based system or it can be a complex-based system. A simple rule-based or it can be a complex self-learning system also. In this, ML is a kind of subset of AI where a system learns from the data to do predictions, to make decisions, and expressly program around it. Okay, so it uses data to find patterns, do predictions, forecast. Okay, there are few issue in ML which we are going to see later, but in that in that deep learning becomes a very specialized subset of ML that uses neural network to understand the different complexity within the data. This layer can be very deep. These neurons can be deeper, hence the word deep came into picture. Okay, but let's try to understand a bit more about machine learning and what are the issues in the machine learning. Okay, machine learning, we have seen it can be divided into two branches: regression and classification. In regression, we have few ways to understand the how good is the model with the help of matrix. So we have seen in regression, we know there are R square matrix, there's RMSE matrix, there is MSMAE matrix, root mean square error, mean absolute error. In classification, we know few metrics like accuracy score, F1 score, recall, and it goes on. Okay, but once we have implemented this model into the production, there is one thing which happens quite often in machine learning, which is called a model decay. What is model decay? So if we put forward in a graph, if we have x and y, if my x is time, my y is score, what happens is that as the time passes by, my model would start decaying. Okay, I can have a good threshold saying that if it goes beyond this, then we have to reevaluate it. Let's say I created a threshold, this is my threshold. Okay, and I said that if my model passes by this point, then I have to reevaluate it. But the problem here is that we have to constantly monitor. There's a constant monitoring which you have to do. Okay, to monitor, then you have to maintain this performance, and in case if data changes over time, then this it's going to decay much further, right? So we have to keep evaluating. If something happens, then you have to redo our modeling. This is something which deep learning has resolved for us. Deep learning, in one side, it is nothing but it mimics the brain through neural networks. Correct? Neural networks are nothing but a component within the whole structure which does some kind of operations. But this neural network can have, there can be multiple neural networks okay, with multiple layers, hence it can be called as it's deep. Okay, upon this there are few advantages of using deep learning. First, it handles large amount of data set very easily. Second, it can understand complex pattern which my machine learning could have missed it, and at the same time it reduces the constant monitoring stuff. Okay, so it reduces the human intervention within the model. Because of these benefits, let's try to understand a bit more inside what happens within the deep learning. So here what I have done, I have taken an example of a neural network which is used in the deep learning. Okay, the example which I'm going to use is very simple. Who would pass the exam? The output can be 1 and 0. What are the features I have? The time to study, how much time a student put forward to study, how much time a student put forward to play, how much time a student put forward to sleep. So we have study, play, and sleep. So this is my neuron 1, neuron 2, neuron 3, neuron 4, neuron 5. There are multiple things which happens within the neuron, but before we try to understand what happens within the neuron, so this is a normal structure of a neural network. Okay, this layer is something which we say it is a input layer. This layer we say it is a hidden layer. This layer we will say it is a output layer. Every neural network would have a input layer, a hidden layer, and an output layer. Good. Now here what we have done, we have went inside every neuron what happens. Okay, I will try to explain with the help of one of the neurons which I have taken here what exactly happens within the neuron. Okay, every neuron would have two activity which it has to do. One is aggregation, which you can see here. So it takes the input from every input layer and then it aggregates it. Okay, and it passes to activation layer, which technically is responsible for giving out the output. Okay, giving out the output. Now once it gives the output, let's for example our y hat, let's say it is 1 or 0, whatever. Okay, if it does something wrong there, so we can understand this with the help of loss function, which is nothing but y minus y hat. The idea is to keep this loss function as small as possible. Now happen to be what happens is that in my first iteration it has aggregated all my input, it has given to the activation function, then the activation function gives you the output and I have gotten response. Okay, so this whole process can be called as a forward propagation. Happen to be if something goes wrong in my predictions, nothing to worry, it can do one more step called backward propagation. In backward propagation what happens is that with every input there would be a weight assigned. This weight is something which the model can actually update or can customize it as per the requirement to have a better output. Now if we try to reconsider the aggregation step, aggregation would consist of the input multiply the weight with the bias. Why bias? Is because, let's say for example, if I assume all my weights are 0, then what is going to happen? Input into 0 plus input second input into 0 plus third input into 0, everything would be 0. So I would have some kind of biasness addition, so it doesn't creates everything as a 0 for activation function. Let's try to understand again. Okay, so every neuron is going to have two functions, aggregation and activation. Sums up, so aggregation technically sums up all the inputs and the weights plus the bias, don't forget the bias, and activation essentially decides what will be the output. There are multiple activation functions in the market or in the community. Okay, I'll just put forward the three important activation function. One is called ReLU, then sigmoid and softmax. Okay, ReLU is technically used for if you want to put forward a continuous output. Let's keep it very simple. Okay, if you want to know a bit more about it, you can always go and read the research papers. It will explain you. If I want a continuous output, at that point of time I have to use ReLU. If I want to output a binary output, which is 1 or 0, at the point of time I will use sigmoid. Okay, if I have a multi-class, classification, at that point of time I would use softmax. So remember this part, and if you remember this part, it would be easier for you. Then you have to understand what happens once we go back to the weights. So what happens is that it technically tries to understand how to optimize it. So we know one of the optimizer, which is the gradient descent. So in gradient descent, what happens, we start with the given weight, and then we try to traverse and try to find the best weight, correct? So in the neural network, we say the optimizer as Adam, which you are going to see in the code part also. Okay, so this is the whole theory, which I've explained in a very short and crisp manner. So this thing in the code, what we are going to do, we are going to work on our first neural network, which is ANN, which is nothing but artificial network. Let's go to the code now. So what we are going to do is that we have taken one example of implementing deep learning. So in deep learning, we can divide the family in three parts again: ANN, CNN, and RNN. So here we are going to see an example of ANN. So in the first part, what we have done is we have brought all the required libraries. The important library which I like to highlight here would be the TensorFlow, right? It is the important library if you want to go ahead and implement deep learning. Okay, so what I have done, I have ran that. I have bring all the libraries which is required. After that, in the next line, what is happening is that we have brought one data to solve a cancer related issue. Okay, so we are going to see a cancer related data set. If you are well versed with the breast cancer data set, so we are going to use that one. Okay, let me run that. So what is happening in this line of code is it is going to bring forward the URL, and we have put forward the important features for our analysis purposes. So here we have done a missing value or quality handle. So we have removed the question mark from the data set. Okay, then we have seen the data for our understanding. Then we have removed the ID column because the ID column is not very important for our analysis. What I'll do, I'll again bring forward the head to show you the ID column is gone. So everything is a feature except my last column, the class. Okay, in the class I have multiple classes. So if you see my class column, it has multiple classes again. So you have to be very careful that you shouldn't use an activation function which cannot handle multi-class. Okay, so once I go there, I'll explain you. So what I'm doing here is that I've assigned my x and y, and I've make sure that I've told that my y is a categorical data set so that it handles properly. Then the very normal step of doing x train and y train. Okay, so I've split the data into 20 by 80 kind of stuff. So my train would be 80%, test would be 20%. I've standardized my data set as required. Okay, after I standardize the data set, here is the space where we have started actually our deep learning concept. Okay, so when we think about deep learning, always remember that we have to build the neural network. Okay, neural network consists of three important stuff, right? One is input layer, second is hidden layer, third is the output layer. So we have to define each and every layer properly. So first we have initialized the sequential class. Then what we have done, we have defined our input layer, okay, we have said that take 16 neurons at the start, use activation function called ReLU, and then put forward the shape and start the processing. My second hidden layer is of again 16 neurons. Activation function again uses ReLU. Okay, my last output output layer. So I have put forward my the output would consist only one neuron, and the activation function used would be softmax. The reason behind the softmax, because it handles multi-layer, multi-class outputs. Okay, now you can ask a question here that why did I use 16 when my features was not even 16? My features were so much my features were, I think so it was 8, 1 2 3 4 5 6 7 8 9. When my features were 9, why did I choose 16? So you can start with 9. Okay, after some iteration I have understood that 16 gives me a better score, so that's why I've chosen 16. Okay, don't make it very high, because if you put very high, yes, it would learn, but there is a very good chance of overfitting. So make sure that you do it properly. Okay, after that, in normal machine learning model, what we used to do is that we used to go and directly put forward in the fit. But here, because as I was talking about, it has backward kind of propagation, right? So if it is going to make sure that once we are going to send for backward propagation, what exactly it has to do? Optimization, right? So here we have defined how it has to optimize with help of the atom. The matrix which it has to look is the accuracy. Okay, now we will say now train the model. So if you see, we have defined some epochs, which is a loop. So it will check 50 times again and again. Batch size is 32. It's going to not send every data together. It's going to send into small batches, and the validation speed is 20%. So it is going to do a training and validation also with the data set. So if you see, it has run 50 times now. It started, the first epoch gave me a score of 33%, then 67, 79, 81, 90, 92. With every loop, it is increasing, it is improving. And at the end result what I have is of 97%. Okay, so I'm going to attach this code also with the video, so make sure that you look into it, and if you have any questions, do let me know. Okay, bye. Hello, thanks for finishing the video. If you have reached till here, it means you have understood three things. You have now understand the pyramid of AI, ML, and DL. Within the DL, you would have understood how the neuron works. At the same time, we have backed up with a hands-on code. So please go ahead and run the code. And if you have any questions, do comment. To understand the next videos, to be updated, please subscribe. Okay, ciao.